Hello and welcome to another video, this time on Mat 2013 question 2. This is for one of the commenters, Primsaran. Yeah, very happy to do any of these questions. Like, just give me explicit instructions which ones you want done, and I'll try and get them done. I know that some other people have written solutions, so if you can let me know which ones aren't available, why not? Why duplicate work? I'll try and do the ones where there doesn't seem to be anything online at the moment. Just to help out where I can, and also the ones which have already been done. I'm obviously doing these for the students I teach at school as well. And if there's already solutions online which exist, then it would be probably more helpful if you could direct me to the ones which don't exist. So yeah, great. Okay, let's have a go at this one. So my thoughts about this one, quite liked it. Obviously, just like, and you can say this about every single Mat question, it's the bit at the end which is hard. Yeah, that is definitely the more subtle bit. But I like this. I thought it was quite a sort of fun question. Part one, we're actually told, the trick, which is always really nice because you don't necessarily see the trick unless you're told it. Now, we're also told, we're given that this function satisfies the identity that f of t minus k f of 1 minus t is going to be equal to t. Yeah, for all values of t, that's the case for all values of t. So it is actually an identity, but they've used an equal sign because that's the kind of thing we do. And we're going to have to determine f of t. We're also told that k doesn't equal 1 or minus 1 as well. And I guess that's because it's in the next part where k equals k equals positive 1, and that's what the second part of the question is all about. But let's just replace t with 1 minus t. So if we do that, we have to do that throughout the whole thing, and we get f of 1 minus t minus k times f of 1 minus 1 minus t. Yeah, it's the t which is swapped for a 1 minus t throughout. And you can do that absolutely with any, function, really. That's what's so convenient about function notation. It's really easy to show when you're making a substitution within the function, and you're always allowed to do that. Principle of substitution in maths is a really powerful idea. So, if this holds, then this must hold. If you like, call t 1 minus 1 minus x, and you've just changed the variable. It's changing the variable, that's all it's doing. Now if we simplify that, we get 1 minus t minus k times f of 1 minus 1 minus t. Well, that's going to be just t, which is beautiful, equals 1 minus t. Now if I just get rid of that middle line because it's a bit clearer what's going on then, all I need to do now, because they want me to find f of t, I need to get rid of the 1 minus t's. It seems obvious, really. If you want to get rid of 1 minus t, we're just going to solve this simultaneously. So I hate the way I really am messy with my maths on this whiteboard, but I'm just going to write down the first equation again, and the second equation I'm going to multiply it through by k, and let me also put the k f of 1 minus t here, so it's all lined up so you can see exactly what I'm doing. I'm multiplying everything by k, so that's k times 1 minus t, and I need to times this term by k as well, so I'm going to get minus k squared f of t. So a slight reordering there of the terms. Then we're going to add it together, and we're going to get f of t minus k squared f of t. We're adding everything, they cancel, equals k times 1 minus t plus t, and then we're just going to do the division at the end, because obviously we can factorize out the f of t to 1 minus k squared, divide it underneath, and you've got the answer. So f of t, apologies for this terrible handwriting, getting worse on this graphics tablet, plus t over 1 minus k squared is the answer. So that's not too difficult at all. Can't remember how many solutions, how many marks that was worth, but probably not that many because it's not too bad. I don't think any of the first three parts are too bad, really. It's the last part which is hard. Okay, consider a new identity, which is where k does equal 1. Okay, and we've got, we haven't got it equal to t this time. We've got to show that when it equals t, there is no function. Well, this is a classic proof by contradiction, isn't it? So assume that f of t minus f of 1 minus t does equal t, yeah? because we're going to assume that it does and then produce a contradiction, and then we can say hence no function actually solves that. So if you like, maybe you like your proof by contradiction a little bit more detail. We could say assume there exists an f of t such that f of t minus f of 1 minus t equals t. Then I don't know if you're familiar with that symbol for there exists, but that's what it means. There exists. Okay, then what can we say? Well, let's, what are you going to try? You're going to try the same trick as before. They're giving you a hint there. Well, remember, this is 1 minus t, and this becomes f of t, because you get 1 minus, well, you get 1 minus, in brackets, 1 minus t. The ones cancel, and the minus minus t becomes t equals t. And so what have we got here? If we add these two together, oh, hang on a second. I've made a slight mistake there, haven't I? Because that needs to be a 1 minus t as well. Oops. Apologies for that. There we go. We all make them. Definitely I do anyway. Okay, then we're just going to add these two equations together. And we're going to end up with something amusing because we're going to get 0 on the left-hand side because they cancel. So this is a plus b, just to make it real clear what I'm doing. They cancel and they cancel. And on the right-hand side, you're going to get 1. Yeah, this is clearly a contradiction. And so we can conclude that f of t doesn't exist. So there is no function for which f of t plus f of 1 minus t. You do want to write these concluding remarks down. Oh, not plus, but minus equals t. Yeah. Okay, and then it asks a more interesting question of, okay, well, if it can't be t, g of t, what condition must a function satisfy for there to be a solution? So, okay, if f of t minus f of 1 minus t equals g of t, yeah, we can just do exactly what we did before. Then f of 1 minus t minus f of t equals g of 1 minus t. We're going to add them together and everything's going to cancel on the left-hand side. So this is really similar. And you're going to get g of t plus g of 1 minus t. And so the condition is that g of t must be equal to minus g of 1 minus t, which is interesting. It's basically saying the function must be equal to the function after it's been reflected in the line x equals a half. I don't know if you're aware of that. If f of x ever becomes f of 2k minus x, that's a function transformation of reflection in the line x equals k. Yeah, I fully invite you to prove that result as well. Go for it. It's a really useful trick to know, I think. So yeah, what we've got here is we're saying basically we need a function which, when you reflect it in the line x equals a half and then reflect it in the x-axis, because the y coordinate's going from positive to negative, you get the same function as what you started with. Yeah. Now that's interesting. Yeah. Now when we get to part C, I've got to be honest. I kind of stumbled on a solution here. I don't think I've got a particularly brilliant way of doing this. The first thing I thought of was, oh, I wonder if my last answer was right. Yeah, and so I checked my condition. Yeah, I checked my condition for 2t minus 1 cubed, because it's like, you want to check your answers when you're doing a question, don't you? And it's like, oh, this gives me a way to check, because presumably this is going to satisfy this condition. Well, if g of t is 2t minus 1 cubed, yeah, then what do we know? Well, we know that g of 1 minus t is actually going to be the same as 2 times 1 minus t minus 1 all cubed, which is, of course, 2 minus 1, which is 1, minus 2t all cubed. Now, what you can do here is you can say, well, I'm going to I'm going to essentially try and factorize out the negative from this. Yeah. And as this is really like minus 1, and so it's a product minus 1 times that, I can cube the minus 1, which is obviously just minus 1. Some of you will just jump to this conclusion straight away, as I did. That's fine. But that's the same as that. And so that does in fact equal. So g of 1 minus t does equal minus g of t, which is basically the same as what I'm saying up here, but just, the minus has just moved over the other side of the equals. And so I was quite pleased that my result held. It kind of shows that my condition, holds from part B, and so it's probably true, if you see what I mean. And just incidentally, backing up what I was saying about reflection in the line x equals k here, if you think about it, what it does what I just said hold for 2t minus 1 cubed. 2t minus 1 cubed is just like, x cubed, but like it's got a point of inflection at x equals a half. Try to draw this really carefully. Yeah. Okay, right. If I was to reflect that, just as I said in the line, now what was I saying? I was saying basically this shows you that you can reflect it in the line x equals a half, and then reflect it in the x-axis, and you get back to where you started. I like interpreting these kind of statements geometrically, I really do. So this is y equals 2x minus 1 cubed. Well, as you can see, if you reflect this in the line x equals a half, you get this, yeah, and I'm going a bit off topic here. And if you then reflect that in the x-axis, you get back to where you started with. So that kind of like a, interesting relationship does hold. So anyway, right, let's do the last bit. So I just, this is, you're not going to get any marks for that, but funnily enough, it did kind of lead to me solving part C. I just wanted to check that like the condition held. Well, in part C, what have we got? Oh, let's change back to my normal pen. So we're trying to solve, just try and solve, find any t, find any f of t for which f of t minus, I keep saying plus, minus f of 1 minus t equals, oh, and we know g of t now, it's 2t minus 1 all cubed. Now, I started off with just a blind guess. I'm like most people, I'm like, I knew that this was going to have an 8t cubed after you expand it. I was kind of thinking like, well, if f of t is 4t cubed, then what would f of 1 minus t be? And it sort of worked out some of it, but it didn't work out all of it, yeah? And, so I basically rapidly gave up because I realized I got the 8t cubed. I also got like a minus 12t squared, but then the last two terms were not quite right. Now, I could have worked on that, and maybe I could have got some mileage out of that. When I looked at the mark scheme, it definitely seemed like that was a possible route. But that wasn't what I thought next. I thought, hang on, whenever you're stuck in these questions, always look back at what you've done. Maybe part one's going to help, maybe part two's going to help, something like that. But it was actually this which made me think, oh, well, surely that helps, because I thought, well, what this is showing you is when you sub in 1 minus t into there, you basically get the negative of what you started with, yeah? Now, just think for a second and think, well, hang on a second. F of t can be any function I like here. So surely, bearing in mind I'm taking away here, if I have exactly half of this, yeah, what's going to happen when I do f of 1 minus t? Well, I get the negative of what I had before. I get if I can highlight it, yeah. What am I going to do when I'm doing minus that? I'm going to get a negative of it, so it's going to turn into a plus. And so as I've got half of it here, I'm going to end up with the right-hand side. I hope you see what I mean there. We're going to have minus 1 minus 2t cubed over 2. This was like genuinely what my thinking was. And that equals, well, let me put the equals down there, 2t minus 1 cubed over 2 plus 2t minus 1 cubed over 2, which obviously equals 2t minus 1 cubed. Yeah. So, it was just that step, that checking step, which kind of gave it away to me. Now, how many marks would I get for this? Because, I don't know how, systematic they want you to be. I mean, What I've often done in the past when I work something out by inspection, you might call it, as I would just say by inspection, as you know, g of t is, well, as g of 1 minus t is a negative of g of t, it follows that we can let f of t, because we're doing f of t minus f of 1 minus t, what that means is if you let it be exactly half, it's going to always just sum to give you the result. And I was really pleased to see, it didn't occur to me that I'd found a general result here. It really didn't. I was just looking at the particular case. But when I read the solutions, it's like, oh yeah, generally speaking, g of t over 2 will always solve it. And of course that's true, because of what we proved here is the fact that that holds. So if you let f of t in this equal g of t over 2, yeah, or sorry, let f of t equal g of t over 2, then it's always going to solve this. It really is. But yeah, I hope like my occurrence made sense. In terms of what I'd actually write down to try and get the marks, I'd say by inspection, as g of t 1 minus t equals minus g of t, what we can do is we can set f of t equal to g of t over 2, i.e. f of t equals 2t minus 1 all cubed over 2. And then I'm just going to show that the result is genuinely true. Then f of t minus f of 1 minus t. I know I've already written this out, but I'm just saying I might be a bit fussy in trying to show the examiner real clear, what I'm doing. Because remember, I'm at pains to point this out to my students. Maths, a maths exam is about communication. It really is. 1 minus 2t all cubed over 2. It's just going to turn into a doubling, and we're going to be absolutely great. Plus 2t minus 1 cubed over 2, which equals 2t minus 1 cubed, as required. Okay, I hope that makes sense. I feel like it's a bit hand wavy. You often do, when you just kind of see something in maths and you think, oh, it just occurred to me that that's the case. But I tell you what it was. It was checking my previous answer, which really let me know, oh, why not use that? That's actually a really useful result, because you know that, you're going to get a negative of what you started with. And look at what we're dealing with here. We want something which, adds to give that. So yeah, it just seemed like the natural answer. Okay, I hope that made sense, and I hope that's useful for you, Prim Siren. Yeah, all the best and best of luck in the mat, and let me know which questions aren't online, and I'll try and do those, because then I can focus, on being genuinely helpful. Okay, all the best. Hope that helped, and bye bye.